Okay. Let's take a look at the review for chapter 11 and chapter 14. You'll want to print these two files off if you can. If not, you'll want to write down the information that they have on there so that you have them available for your review and for your test. Okay, let's look at the review. And we only have 26 questions this time, so it's pretty nice. During which month did Herb incur the most expenses? So we're looking for the highest peak on Herb's color, which is the red. It looks like it's the O, so October. And during which month did Lisa incur the least expenses? So the lowest point on Lisa's looks like this one here in August. So just reading a graph on that one. The amount of electricity used in a typical all-electric home is shown in the circle graph below. And then they want us to answer these questions. If in a certain month, a home used 1,400 kilowatt hours, find the amounts of electricity used from the graph. So what's the amount used by the water heater, by the stove, by the refrigerator, and by the clothes dryer? Okay, so the water heater is 11%, and it's 11% of the 1,400 kilowatts. So 0.11 times 1,400 gives us 154. And let's see. The amount of electricity used by the stove was 4% of 1,400. Gives me 56. The amount of electricity used by the refrigerator is 0.19, 19%. Two, six, six. The amount of electricity used by the clothes dryer was 5%, so 0.05 times 1,400 gives me 70. A well-known major university. Oh, let me start over. At a well-known major university, the career choices of 1,500 graduates from an MS program are shown. And so they ask us how many plan to get a job in a national laboratory, how many are planning to continue for a PhD, how many are planning to enter the nuclear industry or industry other than nuclear, how many are going to continue for a PhD, a postdoctoral position, or other research. Okay, so how many plan to get a job in a national laboratory? Well, we've got the one national laboratory. That's 19%. How many are planning to continue for a PhD? That is 28%. How many are planning to enter the nuclear industry or industry other than nuclear? So nuclear industry is 4%, other is 22%. So that's going to be a total of 26% times the 1,500. And then how many are going to continue for a PhD, postdoc, or other research? So we've got continuing for a PhD being the 0.28 from B, the postdocs being the 0.22, and then other research being 0.05. That total, which looks to be 4055 times the 15. Okay. 285 or 20. $390. And 825. Okay, this one, if you recall, we have to do a lot of like narrowing it down. If you weigh 145, so that's this one here. How many drinks in 3 hours? That's this row here. Would you need a drink to be definitely illegal? Definitely illegal is in the red. So we first get in the red at 5 drinks. So 145, 3 hours, 5 drinks is in the red. Consider the following data set. The annual wages of employees at a small accounting firm are given in thousands of dollars. Prepare a frequency distribution for the data set. So how many 14s are there? 1. How many 16s? 1. How many 18s? 1, 2. How many 20s? 1. How many 25s? 1, 2, 3. And 30. 1, 2. 35. 1. 51. And 60 is 1. draw a stem and leaf plot for the data set. And let's see. We've got 15, 15, 16, 17, 17, 18, and then 21, 22, 27, 33, 34, 50, and 60. And then we draw a line and separate the leaf from the stem. And then we write them 1, 2, 3, 4, 5, 6 for our stems. And for our leaves, we just write them in order using duplication. 5, 5, 6, 7, 7, 8. Then we have a 21, 2, 7, a 33, a 34. No 40s, but we do have a 50 and a 60. All right, so we're going to put in our stem and leaf plot here. 5, 5. Oh, I think they want spaces. 5, 5, 6, 7, 7, 8. Down here we have a 1, 2, 7, 3, 4. We have to write the word none in the 40s. Then we do have a 50 and we do have a 60. 5, 5, 6, 7, 7, 8. 1, 2, 7, 3, 4, 0. Okay. Consider the following data set. Draw a bar graph for the data set. So we have to select the right data set. One thing I see is some graphs have 40s and some graphs don't. So let's check that out. We have a 40, so it's not going to be the two that have a 40 on them. And then what else can we see? We have, well, they look very similar, except there does appear to be 2 versus 1 here. So let's see if we can identify if there's any 44s, because that's 45. Let's see, I don't see any 44s. Here's another thing we can check. Are there 2 56s? Because on this one, it's shorter, right? So there's 156 and there's the other. Okay, so we do have 2 56s. So I think it's going to be this graph. I don't know. I can't tell what the scaling on this one is. 55, 6, 7, 8, 9, 10. Okay, so I don't see, I only see 157. It's also part of my, oh, did I cross off the wrong ones? I must have, because oh my goodness, because I definitely couldn't find the right info. All right, let me restate that. These ones have 40s. Okay, now it's making more sense. These ones have 40s. So it can't be these two. I accidentally said the wrong thing there. Sorry about that. Okay, but now we're back on track. And I definitely didn't see 357s, which is what this stack stood for, right? That tall one there. That one's on the 56 this time, up to the 3. And this one's 56 is at a 1. Let's see. We do have a 56 here and here. Okay. Let's see. I think it's this one. The 56 goes up to the 2. I'm pointing at the 56 now. And we also don't have any 44s, which is something to look at. So in the end, I'm going with this first one. Took me a little bit, but I finally decided. We do have 40s. We have two 56s. We only have one 57, which was in here. And then also, we don't have any 44s, which this graph does have a 44 right here. Okay, so for all those reasons, I'm going with the first graph. Okay, sorry about that. All right, now mean, median, and mode. Okay, so for our mean, we have a formula X bar, which is the sum of the X values divided by the number of X values. There's 5 of those. We've got 10, 20, 30, 40, 50, 60, 70, 5 by 5, which is 14. So we have a mean of 14. We have a median of 14. It's already a sorted list, and we want the middle of the sorted list. So we have a median of 14, and then we don't have a mode. Mode means most frequent, and none of these are more frequent than any others. They want us to write D and E if it does not exist. And we have to write 14 in the other 2 spots. So note to self, no mode. That doesn't mean 0, just means none. Okay, now they want the mean, median, mode again. We're going to use the weighted mean this time. We have 1 plus 2 plus the 3 times, plus the 4, plus the 5. And we have a total of 1, 2, 3, 4, 5, 6, 7 values. The formula we're using is the sum of x times the frequency of x divided by the sum of the frequencies. Here we only had one to worry about, but that's why we used the formula, because we didn't want to add 3 times. We're just going to multiply it and add it once. So that gives us 9, 10, 19, 20, 21 over 7, which is the value 3. So we have a mean of 3. It's, again, a sorted list, and we do have an exact middle. The middle is 3. Also, we have a mode this time because the most frequent value is the x equals 3 value, which we happen to see here 3 times. So 3s. Now, they want us to find or create a box plot for these. Usually you look at your min and max. It's a pre-sorted list for us. The min and max is the same on all of these, but you can see that the Q2 line is different in all of them. Q2 is the median, so let's find the median, right? We've got 2, 4, 6, 8, 10, 12, 14, 15 entries. That means there's an exact middle. 2, 4, 6, 7, and the middle. 2, 4, 6, 7. So there's 7 on each side. And we've got 69 in the middle. So it's not this one at 60. It's not this one at 50 something. It's one of those top two at the 69. And now it looks like if we focused on Q1, we would be able to figure out which of these two is the correct graph. So Q1 is the median of the lower list. And we have 7 entries in this lower list. So we're going to find the exact middle to be 53. This Q1 is not at 53. This Q1 is. So we've looked at the min and max, the Q2, and now the Q1. And we've decided that this is the correct graph. Click. There we go. Did we click that other one? Let me go check. Okay, yeah, it just took me a while to pick it. Okay, now we've got range and standard deviation. So I think we found the mean of this one here, but we can find it again, right? It's the sum of all the x values divided by the number of x values. Here that gives us 15 divided by 5, which is 3. And we need that so that we can find our standard deviation. Range, so we can get it, is max minus min. And that is 5 take away 1 for the value 4. Now our standard deviation, everyone's favorite. Okay, so let's make our chart. We've got our x values. Working on number 11 here. 1, 2, 3, 4, 5. And now we have our x minus x bar. So 1 minus 3. Hold on. I gotta plug in my tablet. Okay, so we have 1 minus the mean, 2 minus the mean, 3 minus the mean, 4 minus the mean, and 5 minus the mean. That's -2, -1, 0, 1, and 2. Then we take that value, that difference, and we square it. So -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared, so that we get 4, 1, 0, 1, and 4. And then we sum the x minus mean summed or squared column. So we're going to sum that. 4 plus 1 plus 0 plus 1 plus 4 is 10. And the variance is the sum of the x minus the mean squareds divided by n minus 1. That's 10 divided by 4, right? And the standard deviation is the square root of the variance. So you want to square root 10 divided by 4, which gives us 1.58. 1.58. And then we're going to do it again for the next problem. Okay, so we'll clear that out. And okay, so let's look at number 12. We need to find the mean of 79, 91, 96, 96, and 98. So let's figure this out. That's 92. So the mean is 92. The range is max minus min, which is 98 minus 79 for value of 19. So let's type that in. We forget it. And then we've got the standard deviation, right? So we're going to do our table. Oh, that's a big table. Let's see, 79, 91, 96, 96, 98. And we'll do our x minus x bar, 79 minus 92. And minus 13. Then we will square those values. Let's see. 169. And then to find the variance, right, we first need to sum that x minus x bar squared column. So let's sum that and then divide by n minus 1. So the sum of this column got 238. So 238 divide by 4. See if it's anything nice. It's not too bad. 59.5. And S is the square root of the variance. So the square root of 59.5 is 7.71. Can't really write down there very well. Okay, 7.71. We'll see in the end if we're right. We're going to hit submit at the end. Okay. Let's see. Okay, find the mean, the median, and the mode of the following salaries of employees of the Mo D. Lawn Landscaping Company. If the answer does not exist for the mode, for example, then write D&E, or it does not exist. So we've got a mean, we've got a median, and we've got a mode. Okay, so one thing is that the mode is the most frequent, and that's the most frequent X value. So that's the 21,000. Now, the median, let's see about that one. The sum of the frequencies, which we'll need for mean anyway, is 4 plus 3 plus 2 plus 1. That's 10 entries. There's going to be 5 on one side and 5 on the other, right? The first 4 values are 21,000. And then we have the 27. And that then we have our middle, which doesn't have an actual value. And then we have another 27, 27, 30, 30, and 45, right? That's what the distribution looks like. So when you don't have an exact middle, you always take the average of the 2 middle entries to find the median. And when the entries are the same, then the median is just going to be that value. So 27,000. And then we need the mean. The mean will be a weighted mean where we have x times its frequency divide by the number of the frequency, right? So we have 21, and if you want to use the zeros, 21,000 4 times plus 27,000 3 times plus 30,000 twice plus the 45,000 once. And then we're going to divide by the sum of the f's, which is 10, which we already found below, right? Okay, so we just stick that in the calculator and trust what it gives us, right? 21,000 times 4 plus 27,000 times 3 plus 30,000 times 2 plus 45,000 times 1. Hit enter, divide by 10, and that gives me 27,000 for the mean. Just like we got for the median. So I kind of believe it. Why not? Okay, so we have another one here. Easiest to see is highest frequency. That's going to be your mode. But mode is an X value, right? So our mode is 70. Now, the sum of the F column is 10, 25, 30. We'll try that again, 15, 20, 30. Okay. And I like to use tables, right? So if these are X's, and this is our F, and I like to make an F column where I just multiply straight across. So 90, 560, 630, 480, 250. Now we can sum our XF column. Let's see. $31. 10, 20. Okay, I think I'm getting 20, 10 when I add that. And our mean, which is here the sum of the XFs divided by the sum of the Fs, that looks like 20, 10 divided by 30. But let me use the calculator. So okay. All right, I'm getting 67. And 67 is within the range of 50 to 90, so it's believable. Oh, it's the mean though, not the median. Okay, now the median. Last time the list was short enough we could write the whole thing out. This time we need to think about the middle, right? So we're gonna have 15 entries, a middle that doesn't really exist, and then 15 more entries, right? And the median is then the average of the two middlemost entries. So we need the 15th entry and the 16th entry, right? So let's count this up in a cumulative frequency way so that we can see when we hit the 15th and 16th entries. If they're in the same row, then it's just going to be that X value. So let's we can erase this and do a cumulative F so we can count. Okay, so 1 plus 7 is 8. 8 plus 9 is 17. So all of the entries up till here is only 8. The next 9 entries are of value 70. The 15th and 16th entries are in that row. And then even the 17th entry is, right? So we've got 70s in the middle, and the average of two 70s is a 70. You can write the list out, though, if you don't believe me. Okay. Be a skeptic. That's what I say. All right. Use the nutritional information about candy bars given in the table to answer the 3 quartiles for serving size. So serving size is the first column. Okay. So let's shrink it down so I can see the whole thing. Okay. So we're dealing with the serving size here. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 candy bars, right? And we need to write this list in order, right? So let's start, it looks like in the 36 will be our first entry. And then we're done with the 30s. Now we've got 40 and a 41. A 42. 42. Another 42. Okay, now we've got a 43. Another 43. A 45. Oh. Okay. After 45, is there another one? Yeah. Okay. 49. Thought I was done. Nope. Okay. Now the 50s. We've got a 50. A 54. 59. Oh, there was a 57. So let's get that on there. Then our 59. Oh, dang, there's two 57s. Okay. Get both of those on there. Then our 59. Okay. I think I caught up. Now, two 60s and a 61. Okay. One thing I did, knowing that there were 20 entries on our list, was I organized it into 4 rows of 5 so that I could easily know in the end if I had 20 entries, and I do. So I trust that we transcribed this list correctly. Now they wanted Q1 and the median and Q3. So half of the list is here. Here's our lower half because its value is lower than the median. Here's our upper half because its value is higher than the median. Okay, so if we look at what's in the middle, we've got two 45s because there isn't an actual middle when you have n equals even. So you have to take the average of the two middles, which is 45. So we have a Q2, which is the median of 45. Then you take the middle of the lower list to find Q1, and you take the middle of the upper list to find Q3. Q1 is 42 because even though there's not an exact middle to the lower list, it splits here between that 42 on the top row and the 42 on the second row. So those two 42s are going to average out to be 42. And then in the upper list as well, you have a 57, then you have the middle and the next 57. So your Q3 is 57. Because your upper and lower list each had 10, there wasn't going to be an exact middle to each of those either. So when there's not an exact middle, you always take the average of the two middle entries. Okay, so let's go enter this in. Q1, Q2, a little wobbly on my desk, 45 should be up a notch, and then 57 is our Q3. And then they wanted us to find, they wanted us to find the correct, I got distracted by the next question. Okay, so draw a plot for the calories from fat. So they're going to make us do each one instead of just one. Okay, so the calories from fat, we've got a min of 35. That might help us, right? So not this one, because the min is wrong. Let's see, max will be 160 on all of them, but look at that third one with the Q3 right next to the max. That means we'll have 5 entries that are exactly the same. Let's see, so look at fat. Calories from fat or total fat? Calories from fat. And are the top entries all the same 5 entries? I don't see anything like that. So I think it's not going to be this one. Here the Q3s are the same and the Q2s are the same. So we'll have to compare Q1s to figure out what's going on there. So let's find the first 6 entries, because remember when we made the list, we only needed this one and this one to make Q1. That's the 5th entry and the 6th entry. And so let's start organizing that list. 35, 70, 70, 70. 90, 90, and that should be our Q1. So we should choose the one at the 90. So we're going graph 1 on that one. And now they want us to do standard deviation and mean for the total fat column. Not too thrilled. Let's see. We're going to count up our tens. 1, 2. So there's 2 of those. Now, how many 12s do we have? 1, 2, 3, 4. How many 8s? We have 1, 2, 3. The number of 13s, 1, 2, 3. The number of 14s, we've got 1, 2, 3, 4. The number of 11s, there seems to be 1, 18, there's 1, 15, there's 1, and 4, there's 1. If we did this correctly, we should have a sum of 20 values here. So 2 plus 4 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So check, check. That's good. Now we're supposed to find the mean, right? So for the mean, we do the XF column. So 20, 48, 24, 39, 56, 11, 18, 15, and 4. And now we're going to sum the XF column. $235. So the mean is the sum of the XFs divided by the sum of the Fs. That's going to be 235 divided by 20 for the value 11.75. Let's put that in. Okay. Now, on each of these, I'm going to switch colors because now we want our x minus x bar. So 10 minus 11.75. 12 minus 11.7. Okie dokie. Now x minus x bar quantity squared. Okay, now I'm going to erase the middle column or one of the middle columns here. Because what we need when we have a frequency table, what we need to add to find the variance is the sum of the x minus x bar squared times f column. So we're going to take our last column we found and our f column and multiply those, because the 3.0625 deviation happened twice, right? The 0.625 deviation squared happened 4 times. So you need the frequency because that deviation happened the number of times that the x value happened. So 50625 happened 4 times. So clearly, if we have issues, it's going to be with standard deviation, right? Because this is such a mess, but I'm just going to stick that in the calculator and add it up. Times 3. Let me go back and fix something. Yep. Okay. Let's, Okay, I'm gonna go back through, just double check my entries. Okay, hitting enter. All right, now I summed the red column. The sum of this column is 183.75. Okay, so the variation is the sum of the deviation squared times their frequency, and then n minus 1 is what we're dividing by still. N is the sum of the frequencies, right? We sum the frequencies to be 20. So we're going to take 183, rewrite that. 183.75. We're going to divide by 19. And then we're going to square root it to find S. So standard deviation is the square root of the variance. So once we get this value, we're going to square root it. And I get the value 3.1098. So I believe we will round to 3.11 for a standard deviation. Okie dokie. Let's hope we're right on that one. Round your standard deviation to the nearest whole number. Dang. So just a 3. Bam. Both of them, or just your standard deviation? Was our mean? Okay, so all right. We have a cumulative percent. So in the first one, we have 0.29, so 29%. By the time we get to the second box, we have 0.29 plus the 0.12 for 4.1, which is 41%. To get to the third box, we have 0.41 plus 0.35, which is 0.76, so 76%. Now we're going to add 8% to what we have, which gets us to 84%. And this next one should take us to 100. So 0.84 plus 0.16 does in fact give us a 1, which is 100%. Let's type those in there. 29, 41, 76, 84, and 100. Now, they want to know, what is the mode? Mode is most frequent. The most frequent is the highest proportion. That is the 35, and it's the X value, not the 35, right? It's the 8-ounce size that is the most frequent. Now, the median happens in the column, well, it's actually the row, where your cumulative percent is first greater than 50. So the 41 is not greater than 50, but the 76 is greater than 50. So for median, we've got an 8. So and in the mean, we have a weighted mean. So let's use our table here. We've got X, and we're going to call it W this time. So the mean is the sum of the X times W's divided by the sum of the W's. I usually use the F because we're in a frequency table, but this time we'll just call it W so we can practice, right? Now, usually I just multiply straight across and find myself the sum, but let's practice writing it out. So we have 2 times 0.29 plus 6 times 0.12 plus 8 times 0.35 plus 12 times 0.08 plus 16 times 0.16. The sum of W is 1. We summed that when we did the cumulative percent in decimal form, right? And so here we're just dividing by 1. You don't have to put that into your calculator, but just so you know, we do have that. It exists. We just don't need to actually write it. So I'm going to just type this in the calculator the way it sits. And I get the value 7.62. Is 7.62 in our range of values? It is. And it's super similar to the median and the mode. So I'm going to put it 7.62, and it says to give it to 2 decimal places. So let's clear that out. And now we have what percent of the total population is found between the mean and the z-score given. So we'll be given a mean and a z-score. The book gives us the area between the mean and the z-score. This z-score is large. So at the bottom of the table, I think they're just going to tell us to use the 4999. So if you look at the bottom, right, there's no see, does it not say it on this table? Oh, there it is. For values of z above 3.09, use 0.4999. So at the very bottom of the table, it told us to use this value here. So we've got 49.99%. Okay, now they have, suppose that people's heights in centimeters are normally distributed with a mean of 170 and standard deviation of 5. Now, if we use the table below, or the chart, we can put the 170 here, right? The 165 here and the 175 here, because we have one standard deviation below the mean and one standard deviation above the mean. And so we would expect 34.1 plus 34.1%. So 68.2%. And we're going to take that 0.682 and we're going to multiply it onto 40 people, because they're asking us how many people, right? So 0.682 times 40 equals 27.28, which we're going to say 27 people. And then how many people would you expect to be taller than 166 centimeters tall? We're going to have to use a z-score at our table because it's not an exact standard deviation distance away from the mean, right? So we're going to need a z-score, which is x minus mean divided by standard deviation. Our x is 166, our mean is 170, and our standard deviation is 5. So we've got minus 4 over 5, which is negative 0.8. Let's double check that. Okay, so we're going to use the table again and look up a z-score of negative 'kay, we're gonna have to think it out too, though. So that we're gonna go look up negative 0.08, and that is gonna give us this info. And then we're gonna add 50 to it because they're asking us for this whole area of the above. But again, the book only tells us the distance we are away from the mean. And actually, they tell us to symmetry. So we do use the table, but we use the positive z-score of 0.08. And then we look for the ending number of a 0. So let me clear this out. Get the whole thing on there. So when we look at z-scores, what we're looking at is the first two numbers and then the last digit. So here is the row that's the 0.8. So that's the 0.8 part of our number. And then we look for the ending digit of a 0. And the overlap is what the book is telling us is between the mean and a z-score that has that positive value. But if we folded our distribution in half, we would see that that space they gave us is exactly the same on the other side. And so we use the symmetry to say that the negative 0.8 z-score also has area 0.2881 between the mean and that z-score. Okay, so now going back to our assignment, we also said that, let me get it back up here. We said, okay, the book told us this was 2881, but we actually wanted all values greater than, because that's taller than 166 centimeters. And so we need to add the 0.5 of the distribution that falls on one half or the other. Okay, so we're going to take our 2881 and add 0.5 to it to find that we have a 0.7881 in terms of the probability that a person is taller than 166 centimeters. Now we're going to multiply, just like we did in the last one, the fact that 78.81% of the 40 people are above this height. So 0.7881 times 40 gets me 31.524. And I'm going to round to 32. See how it goes. Hopefully it's 32. Okay, now we used this one to help us out in the other one. But now they're going to ask us, how many students should receive a C, right? And so if you're getting a C in this class, you're in this range of students here. So again, we've got the 341 plus the 341 for the 0.682, but that's the percent. And we're going to multiply that times the 25 students in the class, right? So we've got 0.682 times 25. That gives me 17.05 students. So about 17 of the 25 students should get C's. And then the group getting A's, that's going to be just this slim section here where we've got 2.2% plus 0.1% for a 2.3%. And decimals, that's 0.023. And we're going to take that 0.023 and multiply it times the 25 individuals in the class. Usually you only have one student who gets an A. Okay. And, oh, 26. Okay. So we're still in the chapter 4 stuff here, or 14. A normal distribution has a mean of 81.5 and a standard deviation of 4.82. Find the data value corresponding to the value of Z given. Enter your answer to 4 decimal places. So Z, let me get a different color. Z equals X minus mean over standard deviation. So to find x, we solve for x in this equation, and we have z times the standard deviation plus mean. So that's what we need to do. We need to take the 0.85, times it by the 482, and add it to the 85.1. I get 89.197. They want it to 4 decimal places. I don't even have 4 decimal places, but we'll still put an extra one on there just in case it matters, right? Um, okay, clear this one out. The diameter of a pipe is normally distributed with a mean of 0.2 inches and a variance of 0.0004. So we need to take the square root of that to find our standard deviation, which is 0.02. Okay. What's the probability that the diameter of a randomly selected pipe will exceed 0.216 inches? Okay, so we need to find the z-score, which is x minus the mean, which apparently here I called m. Sorry about that. And over the standard deviation, x is 0.216, mean is 0.2, standard deviation is 0.02. Okay, let's find this value. I think it's 0.8, which I've seen that z-score before. Let's see. Oh, but we're applying it differently this time. So let's visualize what we're talking about this time. We're not at the negative, we are at the positive, and they want to know area above this mark. The book, however, is going to give us area between the mean and z. And so whatever the book gives us, we need to take that away from 0.5, because your book just gives you half of area. Is that, yeah, I think that's true. Okay, let's try it, see how it goes. So we were here before and we found the 2, 8, 8, 1, but this time we need to subtract it from 0.5, not add it to 0.5. Last time we were adding it. That means on this side, we've got 0.2119, right? 0.2119 plus the 0.2881 that the book gave us makes the 0.5 that is that entire side. And so round your answer to 4 decimal places. We've got 0.2119 as our answer. So Let's clear that one out. Match your equation. So on this one, you want to look at slope. So slope is 0.6. 0.6 is positive, right? So that's the first thing we can see, positive slope. It's not going to be the downhill one. It's one of these uphill ones. 0.6 is 6/10, and slope is rise over run. So we need to go up 6 by the time we go right 10. So we start at a 2 on each of these graphs, and by the time we get to the end, we've gone right 10. So we need to go up 6 by the time we get to the end. That means we should be at an 8. And that one's at the 7. This one's at the 6. So we're going with this graph here. We have an upward slope that goes up 6 and right 10. All right. Yay for these. Okay, so we do have a formula to find R, right? Let's look at that formula. You definitely want these formulas for your test. So write them down unless you're in the online class, and then I'll print them out. I mean, unless you're in the in-person class, and then I'll print them out for you. The online class has to print them out for themselves. And here we have our NaSTL formula, right? But luckily, we just have to understand how to plug and chug it, right? So we've got a numerator of n times the sum of the xy's minus the sum of the x's times the sum of the y's over 2 square root functions, one for the x values and one for the y values. So let's go back to our paper now. All right, so we've got, for R, we've got 10 times 57 minus, okay, so not 57, minus 13 is that one. Okay, so 10 times minus 13, and then minus 57 times 1. Okay, now we're rocking and rolling. Now we have 10 times 353 minus 57 squared times, in the denominator, the square root of the y components. So our y squared is 45. And we're going to take away the 1 squared. Okay. So let's get this into the calculator. 10 times negative 13 minus 57. Hit enter. Divide by parenthesis, square root. 10 times 353 minus 57 squared. Then enter square root, hit times another square root function. 10 times 45 minus 1 squared. Enter square root function, end your parenthesis for your denominator, and then I get the value for R to be negative 0.526. They want two decimal places, so 53, but it's a negative. So negative 0.53. And now we have to find our slope and our our slope and our intercept so we can find our linear equations. So let's go write those formulas down as well. So now we have to find slope, which is the same numerator as r, but only the x information and not square rooted. So that's our m value. B is the sum of the y's minus slope times the sum of the x's over n. So we have to have slope in order to find B. Okay, so let's find M. M is 10 times negative 13 minus 57 times 1 over 10 times 353, take away 57 squared. Okay, let's get this. Okay, so I get minus 0.66548047. We will round it in order to write it in the equation, but we're going to leave it whole to use it to find B. So B is the sum of the y's minus our slope, and you never round intermittently. Slope times the sum of the x's, and then divide by 10. Okay, so this is going to be our intercept term. So by 10. This gives me 3.893, but we're going to round to 2 decimal places. Now, y is mx plus b. So m is our slope, rounded is negative 0.67x. And then we're going to do plus b, so plus 3.89. We'll see how that turns out. Why does the font look different? Okay, we're going to cross our fingers in a minute and then check our work, right? That's all we really can do. We only got a couple left where we solve for n, right? And you had a formula for this as well. So I'll have to remember to include this. If it's not, oh, look, it's right there. So I don't have to remember to include that. We've got the size of n is t squared times p times 1 minus p, all divided by m squared. Okay, so in this equation, p is 0.25, t is 0.95, m is 0.02 for 2%, right? We've got t P, and M. Now N equals T squared times P times 1 minus P, all divided by M squared. So let's try to get this. 0.95 squared. Okay, so I'm getting 423.046, blah, blah, blah. But we're going to round to 423. Okay, now in this second one, we've got P is 0.11, T is 0.91, and M is 0.05. So N is 91 squared times 0.11 times 1 minus 0.11, all divided by 0.05 squared. Okay. Okay. 32.42. So we'll round to 32. And that's it for the review. Logged us out. Let's see if it saved it. If not, then we'll just trust it, and you can ask me questions in class or through emails, right? So let's see if it's there. Oh, I don't even know which one I was working in. Yeah, I don't know which classes review I was working in. So yeah, I don't think it was that one. Guess I took too long. I think it was this one. But all of our answers are gone and the numbers are different now. So hopefully we did the right thing. And if you entered it and it didn't accept the answer, just send me an email and I'll double check your work. We can work it through together. Otherwise, if you're in the in-person class, be sure to ask me questions in person. If you're in the remote class, be sure to ask me questions online. And if you're in the online class, then feel free to send me emails. Everyone can send me emails, and I will, well, I guess my office hours are after your test, but that's for the in-person test, right? So if anyone not in the in-person class wants to ask me questions, I'll be around in office hours on Friday. So please let me know if you have any questions. Otherwise, good luck on your tests